Okay, guys, this is the review for the final exam. So I summarized all the worksheets after the midterm, and I think that would probably be maybe 80% of your final exam. So what I want you to do is make sure you understand everything in this video, forget about everything else. Make sure you understand everything in this video or these videos because it's multiple parts, plus the midterm video. So you need the midterm video after this. So everything today and plus have a look at the midterm review. But this is the main thing. And I highlight in each question, and I'm going to do this again. So have the thing in front of you, what I sent you. I highlighted the keywords in the question. So the first question, the keyword would be finding absolute max, absolute min. So the question, find absolute max, absolute min, they give you the function x squared, xy, y squared, x negative 5y plus 1. Along the region, x0, y equals 4, and y equals x. Now if you sketch this, x equals 0 would be the y-axis, y4 would be this line here, y equals x would be the straight line going this way, and since y and x are equal, so this point would be also 4. So this point is 4, 4, 0, 4, 0, 0. Now to do this, first thing you need to do is you find the critical. You know how to find the critical. You need to find the derivative with respect to x. 2x minus y plus 1, set it to 0. Derivative with respect to y, minus x, 2y, negative 5, set to 0. Solve for this, so you put the first equation, you put the second equation. We need to multiply this by 2. So the first one the same. Multiplying this by 2 give you negative 2x, 4y, and 10. You add them, x cancels, you get 3y equals 9, y is 3. So when y is 3, you plug it back into the first one or the second one, into this one or this one. From here, 2x minus 3 equals negative 1. Bring it over, 2x equals 2, x is 1. So now I know that I have my critical point, and it's 1, 1. So this is my critical point. After you do the critical point, you need to find other points. The other points are the points along the line. So along this line, and this line. So let's try and find the point along x0. Plug 0 into a function. It gives you 0 here, y squared, 0 here, negative 5y, plus 1. Now after you do this, find the critical for this. Derivative, 2y minus 5 equals 0, 2y equals 5, y equals 5 over 2. So now we get another point from the first one where x is 0 and y 5 over 2. That's point number 2. We go along y equals 4. So the function will be all in terms of x only. Put 4, this is x squared. 4 here would be 4x. 4 here would be 16. This is x. 4 here would be negative 20. And this is 1. So the function becomes x squared 3x minus 3. We find the derivative of this. 2x minus 3 equals 0x, or 2x equals 3x is 3 over 2. So we have the point where x is 3 over 2 and y is 4. We find along y equals x, which is the last one. You plug x, so the function becomes x squared. You put x here, minus x squared, plus x squared, plus x, minus 5x, plus 1. So the function becomes x squared 4x plus 1. You find the critical for this. Derivative is 2x minus 4, set to 0, 2x equals 4, x is 2. So we have another point where x is 2 and y equals x, so y would be 2 also. So after finding the main critical and the critical along each line, you also find the boundaries for this. The boundaries are 0.00, 40, 04. So the main critical along the lines and the boundaries. You plug them all into the function. The 1, 1. The 0, 5 over 2. The 3 over 2, 4. The 2, 2. The 0, 0. The 4, 0. And the 0, 4. So I plugged them all, and this one is, the critical was 1, 3. Yeah, if you go back to the video, you see that it was 1, 3. If you plug them all, you see this will give you negative 6. This will give you 21 over 4. This will give you negative 21 over 4. The 2, 2 will give you negative 3. 0, 0 will give you 1. This will give you negative 3. And this will give you, this is the other boundary here, 4, 4. And the last one will give you 1. The minimum is this. This is the absolute minimum. Maximum is 1, so absolute max, absolute max. But remember, the points we need to do, the main critical, the critical along the lines, and the boundaries. So, question 2 is also another example of absolute max, absolute min. So, question is, find absolute, again, the key word here, absolute max, absolute min. For the curve, this is question 2. For the curve x squared, y squared, minus 2x, and it's on the region x squared over 4, y squared equals 1. If you look at this. This here is an ellipse. The number here 4, so the square root of 4 is 2. So in the x direction, you're 2 and 2. So this is 2, this is minus 2. In the y, there is no number. You can assume it's 1. So it's 1 and 1. So 1 and 1. So it will look like this. Three things. Main critical. So we do the main critical first. So fx, fy, 2x minus 2 equals 0. 2x is 2, x is 1. The y, we do the derivative for this in the y. So y is 0. So the main critical is x1, y0. Now we do the critical along the line. Along the line, this is the curve. This is the along for you. There are two, you can look at it. You have the positive path and the negative path. If you do the positive path, it would be y squared equals 1 minus x squared over 4. So you take the positive root. So this would be the first path, so we can do along this. And obviously the negative path is when you take the negative root. So to do the positive path along this, so you plug this into your function. The function becomes in terms of x only. This is x squared. Replace this by this. You square it, it becomes 1 minus x squared over 4 minus 2x. So the function is x squared minus 1 over 4x squared becomes 3x squared over 4 plus 1 minus 2x. We find the critical for this. 2 down would be 3 over 2x minus 2 set to 0. 3 over 2x equals 2. X equals 4 over 3. And when you plug it back to find what y is, 1 minus 4 over 3 squared over 4. Well, you have a calculator. When you plug it back, you get y to be root 5 over 3. So we have the other point of 4 over 3, root 5 over 3. That's your second point. This is when you do along the negative path. But if you do it along the positive, if you do it along the negative path, since you're gonna square, you end up with the same thing. You're gonna square the y, so you end up with the same thing. It will eventually be the same point. But when you plug it back into this, it will be negative. So it will be the same point for the same x, but negative y. These are the 2 points for the critical points along the lines. The last thing we need to do is the boundaries. We have 2, 0, 0, 1, negative 2, 0, and 0 minus 1. These are the boundaries for the system. So we have 7 points. You plug them all into the function. The 1, 0, the 4 over 3 root, the 4 over 3 and negative the root. And then the boundary is 2, 0, 0, 1, negative 2, 0, 0, minus 1. This one gives you minus 1. This one gives you minus third. This one gives you minus third. And then you have 0 here. 1, 8, and 0. This is your absolute max, and this is your absolute min. Good? So this is the question. There will be probably one question for absolute. Question 3. Question 3 is finding the max min using Lagrange multiplier. So there are 2 questions we're going to do. This is, okay, the first one we finish, absolute max, absolute min. That's the first idea. Then the Lagrange. Lagrange, you will be given a function either to max or min. In this question, it's 3x minus y plus 6. And you're giving something called subject to. The constraint x squared, y squared, this is subject to equals 4. So you bring this over, x squared, y squared minus 4, and you call this function g of xy. This is g of xy. Again, this is the function you're maximizing. This is the subject to. So the subject to, you bring it over, bring the number over, is this. What you need to do is you find the derivative for this. Derivative with respect to x is 3. Derivative with respect to y is negative 1. You also find the derivative for g. With respect to x is 2. With respect to y is 2y. Then you apply the Lagrange, which is take the derivative, lambda, derivative. So I look at the x's, so you go 3 equals 2x lambda, or lambda equals 3 over 2x. And here, negative 1 equals 2y lambda, then lambda equals negative 1 over 2y. Lambdas are equal, you said these to equal each other. So 3 over 2x, negative 1, 2y. Do the cross multiplication, 6y equals negative 2x, or basically y equals negative 1/3 of x. Once you have your y, you plug it back into the constraint. So you have x squared, this squared, which is 1 over 9x squared, minus 4 or equals 4. This plus this is 10 over 9x squared equals 4, which is x squared equals 36 over 10. Then x equals, you square root, so positive, negative, square root of 36 and square root of 10. So x is 6 over root 10, and plug it here to find y. Y would be minus 2 root 10, so that's the first point. Or x equals negative 6 over root 10, and from here, y would be positive 2 root 10, that's the second point. Since you're maximizing, you plug them both into here, into the function. 6 over root 10, negative 2 over root 10, and negative 6 root 10, positive 2 root 10. If you plug them for this one, you get 2 root 10 plus 6, and here you get minus 2 root 10 plus 6. That's your max, and that's your min. So again, the Lagrange, basically, you get a function and the subject too. The function is whatever you maximize or minimize. So you find the derivative with this, the derivative of this, you apply this, you find the relationship between y and x, you plug it back into G to find what x and y are, you find your points, you plug them back. We'll do another Lagrange question. I'll stop this video because it will be hard to upload it. So I'll stop it. We'll start with part 2.